So in this video, we're learning about the percent mass over volume concentration. So here you're looking at describing a concentration as a mass of a solute, so in grams. So maybe you've taken a little bit of sugar, you're dissolving it in some water. So you take the mass of the sugar, the solute, the thing you're dissolving, you divide that by the volume of your whole solution in milliliters. So notice in this equation, these units no longer cancel. So in our percent mass over mass, right, we had grams over grams, and we ended up with just units of percent. Percent volume over volume, we had milliliters over milliliters, we end up with just units of percent. But in the percent mass over volume, we're going to have grams over milliliters here. That doesn't cancel out. So just a faster way to write that equation, we can write it as percent m over v, just a little faster than writing the word percent. And then, of course, the mass, we use the symbol little m for it. Specifically, we're talking about the mass of the solute, the thing being dissolved. And the volume on the bottom is the volume of the entire solution. So you're going to use capital V for volume, and you can write solution to indicate what the volume is about. The units, notice again that these units don't cancel, right? So those grams and milliliters have to stick around. So the way we write the units is we say it's percent grams per milliliter. So this is a longer unit, but that's your unit of percent mass over volume, percent grams per milliliter. Let's try one example with this altogether. So let's say you're making an intravenous solution for a diabetic patient and you need some glucose. So you take 17.5 grams of glucose, you're dissolving it into some water to make a 0.350 liter solution. We want to find what is the percent mass over volume concentration of the solution of glucose that you just made. So let's write down our given information here. The first number that I see coming across is this 17.5 grams. That's a mass, and it's the mass of glucose, which is my solute. So it's a mass of my solute. Little m is my symbol, and I'll put a subscript of solute there, or you could just write glucose because glucose is the solute. So a mass of glucose would be fine too. The units of that are already grams, which is the units that I like, so things are good in unit land. Now the next number that I come across is 0.350 liters. So here, the units are not right? I need to write that down in milliliters. To convert milliliters to milliliters, I just need to multiply by 1,000 because there's 1,000 milliliters in 1 liter. I'll just write that unit conversion out for you just in case anyone would like a hand with that. So it's 0.350 liters. The thing that I need to cancel is liters, right? So when I multiply by a fraction, I put 1 liter on the bottom, and that's in order to cancel the liters. Then the thing on the top of this fraction has to be what 1 liter is equal to. 1 liter is equal to 1,000 milliliters, so I'll put that on top. There's my 1,000 milliliters. The liters will cancel, and I'll be left with units of milliliters, which is what I want. So 0.350 times 1,000 is 350 milliliters. So now I've got the right units for the volume, the right units for the mass. We can write down our required. The thing we're trying to find is the percent m over v. So the short form for that would just be symbol percent and then m over v. The equation that I need here, now this is an equation, notice that's not on your equation sheet, so just something to watch out for our course. This is an equation we need to know. It's easy to memorize though, or easier to memorize I think, because the words themselves really give you the equation, right? The percent mass over volume is the mass over volume times 100%, which kind of makes sense. One thing that's nice about it is it's already rearranged for what I want, which is the percent mass over volume. So I just have to plug in the mass of my solute in grams, plug in the volume of my solution in milliliters, and I'm good to go. The number that I get here is 5. That's what comes out of my calculator, but I need to use the right significant figures. There's 1, 2, 3 significant figures here, and 1, 2, 3 significant figures there. So I'm going to need 3 significant figures on my answer. So it's 5.00. That indicates how sure I am of this concentration. And make sure you get the whole unit, it's a longer unit in this case. Percent grams per milliliter is the correct unit for this problem.